Hello, nice to meet you all Poland engineers. My name is Eddie Hong. I am Technical Manager for nGen. This is the first nGen webinar in Poland this year. I am planning to meet you in many webinars in this year. Today's topic, as announced in advance, is to tell you about how to generate drawings using nGen and drawing programs for RC structures. Okay, let's start. The table of contents is as follows. First, I will briefly explain the composition of the nGen program and the role of the drawing. Then explain the function of creating a user-defined drawing sheet directly and arrange the automatically generated drawings in the sheet. Lastly, I will tell you how to set the create Barbarian schedules for various members that can be generated based on the Eurocode. In Chapter 1, I will briefly explain the composition and the key features of nGen programs. There are two configurations of nGen program, which is nGen and drawing. The first nGen, which can perform structure analysis and design. The second is MIDAS drawing, which can do like CAD like AutoCAD or automatically generate structure drawings by recognizing nGen information. Therefore, there is no need to buy and use CAD programs if you purchase MIDAS nGen software. MIDAS drawing is alternative CAD and information CAD are possible at the same time. nGen has three modules: Steel, Concrete, Advanced module. The BIM interface function has been enhanced. It will be provided as a MODS module along with the MIDAS drawing program. I will explain the function of MIDAS drawing, which is separate two modes. The CAD mode can be used as an alternative CAD like AutoCAD. It is possible to set Cad Command by user-defined, and it is possible to provide basic lists and even settings. Of course, if you buy one of the modules of MIDAS nGen, you can use MIDAS drawing. Also, one of the biggest features of MIDAS drawing is that it has function to generate design information as a structure drawings. In the drawing mode, you can create several Eurocode-based structure drawings. It is also very easy to use, so you can learn quickly. I would like to briefly explain about the model we'll be using in today's nGen webinar. It is a 5-story structure with reinforced concrete only. There are A-E grids in global axis and 1-4 grids in global y-axis. We will look into number of design information in the tree menu. "25 megapascal was used for concrete compression strength. In terms of used members, beam, column, wall, slab, and flat slab are used in the upper structure. and there are isolate footings and strip footings at the substructure. There is an opening on each floor and it will be displayed when we generate a drawing. You can check the input load from the Analysis tab in the Worktree menu. We can see dead load, live load, Eurocode-based wind load, and seismic load. I will assume that the design of this structure is completed. So we will move to Table tab and check the final design for Levi data. You can double-click the members you want to see from the tree menu and check the details about a Bim member. You can not only check from design group to the name of member, but also how much levers are located on top and bottom. You may also edit the information from the table, just like Micro Excel. You can easily input the text. The data input is completed for other members such column, wall, slab, flat slab, isolate footing, and strip footing. Because today's main topic is focused on generating a drawing rather than designing a member, we will go straight into the main topic. I will click Report and Drawing tab and check the information that will be exported to our drawing. Plan drawing, level information, foundation, rebar arrangement, slab arrangement, and you can also check the pile arrangement. You will see the cutting position and view depths from here. If I click the dialog of the third floor, the third floor will be highlighted in the view window. If I zoom in 1.5 meter to jet plus direction on the third floor, will be cutting position, and 3.0 meter to jet down direction from the 1.5 will be view depth. This means that all including members are displayed in the plane drawing corresponding to depths. If you wish to change the cutting position and view depths, you can manually type to change it and check it on the view window in real time. For example, if a revision is needed or design data such as the floor information is changed, I recommend you to auto-generate the information by clicking the Reset button. If you have checked all information, click OK button and click Generate Drawing to run MIDAS drawing. As you can see it on the screen, this is MIDAS drawing program. You can see there are a lot of menus, but the key point is that the Generate Drawing tab from the main menu has the functions to import all information from MIDAS engine to generate drawing automatically. The menus on other tabs are very similar to AutoCAD. So remember, auto-generating the information CAD or the information from engine to structure drawings are all done here and other functions. The next most important part is the list of menus in the Window tab of Worktree. The Window tab is formed of three modes: template mode, drawing mode, and CAD mode. So the structured drawings that are generated from engine's data are all listed in the drawing mode. It will be easier for you to understand when I demonstrate this shortly. And from CAD mode, like I said earlier, you can use functions like edit and draw just like AutoCAD. Lastly, template mode allows you to save templates of your own style and allows you to automatically generate structured drawings such as layers. From now on, I will explain the drawing creation function, the main topic of the day. How to create a sheet in your own company style. I assume companies have their own sheets that they use very often. From now on, I will explain how to generate a sheet in your style and use it in a project. From the three modes, double-click the CAD mode. Now you are in a mode where you can draw like AutoCAD. From the Worktree, we will click Draw Library tab. I will create our own sheet. To create a sheet, I will drag a sheet from Window Object and drop in the View window. Then I will type the sheet name and just write ABC Company and set the scale as 1:100. Then OK button. Type 0,0 in the command menu and insert the sheet. So the sheet you see on the screen will be the basic sheet we provide from our company. It's registered as MIDAS sheet A3. this seat is registered as AB's company with the scale of 1 to 100, and when I set the auto-generate structure drawing into this seat, the project name will be automatically updated. You can see that this seat is made of a block, and I will type X in the command line to operate explode function. If you see individual objects of all separated, and I will edit from here. First of all, delete the unnecessary part and delete the logo, and to replace it, we will use move command to move these objects. And C command to copy it. If necessary, you can use the trim function to work on it. You are seeing the process of editing the seat based on my needs, just like AutoCAD. I will leave this object because this part needs to be on information CAD and move it to an appropriate location. Lastly, I will use match property command to change the color of the layer. Due to the time limit, I will finish editing here. In order to set the scattered object into one block, I will type shortcut B in the command line and create a block. Because it is set as a block now, you may check the block list from the worktree. Set the block, then OK button. You may check the block list from the worktree. The next step I need to do is to type sh in the command line to register as a seat. Type sh. We will define the name and scale of the seat and designate as an object and hit OK from the dialog. You can see the seat registered in MIDAS drawing. If you look at the worktree, you will see AB's company seat. If you drag and drop from the work tree, 1 to 100 row seat will be generated. Because this ABC company seat will always be used in my project, I will register this in project object by drag and dropping. Now user can use this seat whenever the user needs it. Because it is registered, the seat can be arranged using the drag and drop function. The scale of the arranged seat is 1 to 100, but MIDAS drawing is on information CAD. You can just add it to 1 to 150 scale automatically. Of course, the seat can be made again using the copy function. I will make 1 to 200 scale seat as an example. I will end my explanation on creating, registering, and arranging your own seat. Now we have created the desired seat, so we will place various automatically generated structure drawings in the seat. The types of drawings to be arranged are floor plan, evaluation, member list, drawings for various members, and detailed drawing called Barbarian schedule. I will now arrange the auto-generated drawings in multiple seats. Because I have not generated the structure drawing yet, I will do that first. Let's go back to Window tab in the work tree and change to drawing mode by double click. Right now there is nothing, but you can see the list of seats I've arranged in the CAD mode list. I will go back to Generate Drawing tab from the main menu and create plain drawing. I will generate the floor plan drawing on 3rd floor and 1st floor. The default scale is 1 to 100, but you can edit the scale from the dialog. You can see the process bar, and this will be processed only one time. Now all the 3D figures and design information from nGen have been transferred to MIDAS drawing. After clicking the appropriate position, click one more time for the drawing's arrangement interval. You can either arrange right next to it or add some gap. So we have to click total 2 times. The first floor will be level 0 and will show the foundation, column member, and group names. On the top right, number of different information is displayed. You can check the grid information on X and Y, as well as the drawing name and scale information on the bottom. If you check a level 6 meter information, you may check flat slab, wall member, and opening, beam member information along with the draw panel. You can also display the rebar information on the floor plan for Bim. And you can also check top and bottom rebar information and rebar interval for both ends and middle area. You can see the slab level difference. Lastly, you can check the flat slab and draw panel information on the wrist. After creating the floor plan of the foundation, you can check the information such as the main rebar for top and bottom, basic measurements, and the distance from the center line to end. Regarding the direction, it is already set in nGen 30 degrees to northwest direction. Now that we have created a floor plan, so we'll create a elevation section drawing from the floor plan. Elevation drawing name will be section 1, which is a default name. When you create elevation drawing, whether it is direct line or diagonal line, the user can set to either one and create the cutting view of that area in planned drawing. I will now create cutting view section drawing and this will be called section 2. There are two ways to create section drawing in MIDAS drawing. The first method is to select the area where the user wants to create the section drawing. The second method is to use axis offsets function from the main menu. Click grid line and hit spacebar to set the depth and create section drawing. Once again, I will click the grid in different area to create a section drawing. We've created section drawing using the second method. To recap, Use the first method when you want to create the section drawing in the area you want. Use the second method, axis offset function, if you want to create the section drawing based on the grid. We will now create member list. It is widely used in the world, and you can get the member list from different members from nGen. We will get Bim, column, var, and etc. We don't need to check on members manually because MIDAS drawing recognizes automatically. If you click OK button from dialog, the member list is generated and arranged in the appropriate section. If you look at the column list, group name, vertical lever, hoop lever information are displayed. For other members, vertical lever distributed in 4x4 P16 diameter, and you can check the shear lever information and interval. You can also check the var member list based on the member group name. You can confirm the information on vertical and horizontal levers. Likewise, if you see the beam list, both ends and middle section information and lever information can be checked. And for the plate member, you can check on isolated footing, the main lever and shear lever information for top and bottom is displayed. So we went through the key features and methods on auto-generating structure drawing. We've created it for the floor plan, rearrangement for slab, creating elevation drawing in different ways, and member lists as well. The created list of structure drawings can be seen in the tree menu under Drawing Mode. Now we will arrange the structure drawings in the sheet. You should use Cad mode for arrangement and editing. Double-click Cad mode and use Shift key on the tree menu to select all and drag and drop to view window. It has 1 to 100 scale. I will use move function to move it to the sheet. Other drawings are 1 to 100 scale, but I will move 1 to 150 scale to the sheet this time. Due to the characteristics of information drawings, the automatic scale has been changed to 150. So the scale has been automatically set based on the scale of the sheet. In addition, you can see the project name and drawing name have been automatically updated. This time I will arrange several drawings in 1 to 200 scale sheet. Based on user's needs, user can edit like Cad. For example, you can use stretch function to edit it. To recap, arrange the seed that you use often in CAD mode. Drag and drop auto-generated drawings from drawing mode to CAD mode and arrange it in the seed. Then you can edit it according to your needs and apply it to your project. The Barbarian schedule drawing generated by MIDAS drawing is for beam, column, wall, and slab members. These details drawings are based on Eurocode and are automatically generated in consideration of lab splices, development, and fabrication lengths. I will explain the setting method and principle to create a detailed drawing. Today's final topic is the detailed drawing of the barbending schedule. Detailed drawings of beam, columns, and walls can be generated by clicking Generate Rebar Arrangement in the main menu. First, you can confirm the name of drawing, corresponding label, position of the grid, and the group name of the continuous beam. And you can check the information by clicking the tab for the column wall basement wall in the dialog box. Returning to the beam tab, click the manager command at the bottom of the dialog box to explain in detail the drawing principle and expression method of the detailed drawing. The Manager dialog box also consists of several tabs. The most basic settings are made in General tab. You can also make the output unit system of the drawing is set to millimeter but can be changed. This is very important function, so if you set the reinforcement using this function, the drawings are expressed according to the setting. The default of Eurocode is expressed in this way like P sign. If you change the setting to pi or sharp, the rebar diameter expression will change. If you want to express other than these three expressions, you can edit it by typing it yourself. The following is to set how place the shear rebars. In the method of above picture, there may be remaining ranks when the spacing of shear rebar. This is a method that accurately calculates the length of the rest at both ends and places it. The below is a method of placement in the middle area at equal intervals. The following is the setting of rebar detail. In this part, you can check the ranks calculated by the Eurocode based for the spliced and development, and also confirm the ranks the hook rebar according to the condition of the rebar. And you can set the fabrication length of the rebar. This is very important setting for splice. The length of the rebar pursued at the factory is set, and the splice and development length will be changed accordingly. Splice method can also be selected as 100%, 50%, and no splice. The band lengths and detailed ranks for developments are set according to the code-based calculation. Rebar length is calculated for not only main rebar but also seal rebar and standard hook. Each of these calculations and expressions depends on whether it is splice and development located in the tension part or compression part. Of course, all calculations are provided by design code and can be changed by typing. If you want to express all the data just explained, check all, then click OK. Next, move to the Bim Coder tab. You can make detailed settings as shown in the picture by clicking Detailed Setting. Character A is set to 25% of the ranks of span, and character B of the inner is set to the ranks of 30 of the span. You can also set the ranks of C and D. I've explained for the top floor, and the other is for the middle floor. And the strut offset distance H refers to the setting that the shear reinforcement will be 50 mm from the end. This is the explanation about how to express the assembly method of rebar. Let's express it both at the top and bottom. And set it up in type A. The following is to set about the splice method. You can select whether to set the max value or each beam. Since the current lever is 8 meters in length, if it is set to max, all the 8 lever will be used to connect. But the other method of each beam may not be able to use all 8 meters when the length of the member is short. So I will set it to max to make a splice. Following is the Eurocode method. We recommend the typical anchorage hook type. Finally, I will check on all the details parts of mark to be expressed. Next, if you click Detailed Setting for the column member, the numerical setting part appears like beam, and the L0, LST, LDT, LGH parameters will be expressed as the numerical value checked in the General tab. The word member is also same principle. Let's create a sample for detailed drawings of the word member. You can check the location with the key plan and confirm the cross-section for section A5-A5. And if you check and click each assembled object, it is displayed as a dot line in the vertical detail view on the left, and you can check the location. You can also see cross sections in different locations. You can also check the information on the vertical main rebar and also confirm the elevation of each ravel. It is confirmed that the development at the lower end is also well expressed. Because it is bar bending schedule, information about all rebars is displayed in a table and quantity is calculated. When creating a structure drawing or detail drawing automatically, when repeating the previous action without clicking the main menu every time, simply press the spacebar to execute the function again. Next, let's create a detailed drawing for Bim. You can check the anchorage of the edge, group name, grid line, area, where you can see the cross-section, the bench length of CL rebars, the mark of the all rebars, length of the main rebars, the splice length of the tension, and the assembly length at the edge. Finally, let's create a detailed drawing of the column member. The principle of creation will not be very different from the beam or word member. It includes the expression of the anchorage with the footing, I will select all members to generate the columns at once. processor bar is in progress. There are dozens of drawings, but it doesn't take too long. All have been created. You can also check the list of the created drawings on the worktree. Double-click the CAD mode and then drag and drop all automatically generated drawings in the CAD mode. Place the seat as you did before and place the detailed drawings. I repeatedly drag and drop and seat. I will move it auto-generated drawings to the seat. Okay, currently the current view is exported as DWG CAD file using the export function. The file has been saved in DWG format. If you double-click the saved DWG file, you can open it directly with MIDAS drawing. So far, we have explained how to generate drawings using nGen MIDAS drawing for general RC structures. If you have any questions about today's topic, I will answer them in detail. Please tell me.